at absorbing long-wave radiation. Okay, but humans, we don't really have any control over water vapor. Water vapor, like the warmer the air, the more energy there is to make gas or to make water go from a liquid to a gas phase. And so as the climate warms, we have the ability to put more water vapor into the air. And that is a greenhouse gas, and it's a positive feedback loop. It creates even warmer atmospheric temperatures. But as we've learned already, water vapor varies from place to place and from time to time. It's a highly variable gas, okay, because it evaporates and then it condenses and so on and so forth. But I just want you to know, greenhouse gas, okay, number one. Second most abundant, we've been talking about this gas already, carbon dioxide. Carbon dioxide, humans are adding more carbon dioxide to the atmosphere in the burning of fossil fuels. Those are basically dead life, right? That's a fossil that's been buried, and we can burn it in the form of coal and oil and gas. And when we burn it for energy, carbon dioxide is released. Just like we release carbon dioxide from our body when we use up energy. We breathe in oxygen, break our molecules, release carbon dioxide. We do that with our fossil fuels. So we're taking all of this carbon that's been buried over millions of years, and we burn it over a very short period of time, adding a lot more to the atmosphere. So CO2, very important greenhouse gas. Another one is methane, CH4, methane. Okay, molecule to molecule, methane is much stronger than carbon dioxide, but there's less methane. Nevertheless, it's a very important greenhouse gas. We do get methane released from the burning of fossil fuels, and also when things like permafrost melt, we get methane. So anyway, we're not going to go into all of that. This is more in the realm of our global climate change class, talking about that. Okay, but I want you to know these major greenhouse gases. The next one, known as laughing gas, nitrous oxide, N2O. Also, molecule to molecule, more powerful than carbon dioxide, but there's not as much of it. But it's really powerful greenhouse gas. The next one is another very important gas that we've been talking about, ozone. Ozone's also a greenhouse gas. It has the ability to absorb long-wave radiation as well as UV radiation. So it's an important greenhouse gas. I want you to know 5, these 5 major greenhouse gases. And there's also what are called CFCs, chlorofluorocarbons, CFCs. Here, I'll go ahead and spell that. Chlorofluorocarbons and hydrofluorocarbons, or HCFC. So just put a hydro in front of that other word. Hydrofluorocarbons, not chlorofluorocarbons. Those actually can be both HFCs and HCFCs. Okay, so those are also implicated, CFCs and nitrous oxide. They're implicated with the destruction of ozone in higher up in the atmosphere, in the stratosphere. So those are actually the results of, or the cause of the hole in our ozone layer. So they're not only greenhouse gases, but they also destroy ozone. Okay, which is bad. Ozone in the upper atmosphere. So we want ozone in the upper atmosphere. We don't want it in the lower atmosphere because it is a greenhouse gas. And the greenhouse gas is causing more and more heat to be in our atmosphere, increasing temperatures around the globe. Let's look at the difference between natural greenhouse effect and accelerated greenhouse effect. So why is it a greenhouse effect? Because similar to a greenhouse, shortwave sunlight is allowed to enter through the glass. Then what happens in a greenhouse is various objects in there absorb that heat and radiate long-wave radiation. The long-wave radiation doesn't pass through the glass in the greenhouse. It gets trapped. So it keeps it nice and warm. Oops. Keeps it nice and warm in the greenhouse. So places in the winter can grow plants. Now, if you haven't been in a greenhouse and experienced that effect, you've experienced something similar in your car. So in your car in the winter, it's kind of nice. In the summer, it's awful. So you have sunlight entering your car through the glass. It heats up your upholstery and the surfaces, and then the long wave radiation gets trapped and it heats up. That's why you can't leave people or pets in your car with the windows rolled up. The greenhouse effect is going to kill them. It gets too hot. All of that heat gets trapped in there. It's awful. It's so sad. It's so sad. It's deadly. Okay, but here's the thing. If we didn't have the greenhouse effect on Earth, our average temperature would be below freezing. The atmosphere would be below freezing because that long wave radiation would just leave and it would be cold. It would be like the Earth doesn't have a jacket on, so it can't keep itself warm. So we need the greenhouse effect. The greenhouse effect is important for all of life on Earth. It gives us the climate and weather that we're used to, the temperatures that life has become accustomed to. But if we accelerate this, temperatures increase and suddenly it's not what life is adapted to. And all sorts of things happen. We're experiencing a heat wave right now as I'm writing this. Species have a limited temperature range from which they can thrive. If temperature changes slowly, climate changes slowly over thousands, tens of thousands of years, life has a chance to adapt and move to the climate where they can live. If it happens rapidly, you don't have that time to adapt or to move. All right. So the accelerated greenhouse effect is not good. Greenhouse effect, good. Accelerated greenhouse effect, not good. So we see here on the left, the natural greenhouse effect. We've got nice solar radiation coming in. Some of it's reflected, absorbed, whatever is emitted as long wave, right? It's not really re-radiated. It's radiated as infrared, okay? Nitrous oxide, carbon dioxide, methane, all of those greenhouse gases absorb it. Some of it escapes out to space. Some of it gets directed back to Earth. This is really an important cycle. In here, in the intensified by humans, we're adding a lot more greenhouse gases, and so there's more being radiated back to Earth, and then that can radiate and still get absorbed, and it heats up in the atmosphere, and you have less escape into space. So not good. Okay, so I want you to know the greenhouse effect, both natural and accelerated, the various greenhouse gases. Again, this is important for life. It's good. not good, accelerated. Okay, I'm going to end there. The last thing that we're going to talk about in the next video, I don't know if it's the last thing, but we're going to talk about the different levels of the atmosphere. So I'll see you then.